Now let's solve this problem, right? What is the bullet is shot from the surface of the moon, right? At some speed. What is its speed at some height above the moon, right? So this guy. There we go. So we're going to have to figure out the speed it is when it's 300 kilometers above the moon's surface, right? Okay. Remember that, of course, it's going to be going slower than the speed you launched it from the surface, right? So if you launch it at 1,050, when it's 300 kilometers above the moon's surface, it should be going slower. We're hoping that it'll be some answer like that, right? All right, so how do we do this? I think the first thing to do is to figure out what is our distance from the center of the moon when we're 300 kilometers above the surface, right? So the second radius, when it's 300 kilometers above the moon's surface, the second distance from the center of the moon is going to be the radius of the moon plus 300 kilometers, right? So 1.737 E6 plus 300 kilometers. Kilometer just means 10 to the third, right? Right, I'm pretty sure that's 2.037 times 10 to the 6, but let's just do it. 1.737 E6 plus 300 E3. And I get that the new radius, okay, above the surface, or from the center of the moon, right, is 2.037. These are commas. Okay, meters. Okay, so here we are. We've got the moon. We've got the bullet leaving the surface of the moon at 1,050, and then we want to know at some height what's its velocity, right? Okay, so let's set this thing up. Okay, so let's see. So it's going to be, it's 2.8 grams, right? So it's the kinetic energy would be 1/2 0.0028 times 1,050 squared, right? Plus the opposite of G times 7.35. That's the mass of the moon. Times 0.0028. And then that is divided by, we're shooting it from the surface of the moon, right? So we'll use the radius of the moon for that, our distance from the center. Okay, now when it's 300 kilometers above the surface of the moon, right? Oops, sorry. This is going to equal 1/2 0.0028 times some unknown velocity squared, right? Plus the opposite of G times 7.35 E22 times 0.0028 divided by, and now this is our new radius, right? When we are 300 kilometers above the moon's surface, we are 300 kilometers plus the radius of the moon from its center. So 2.037 E6, right? Notice that the R's are not squared. Notice that the gravitational potential terms are negative, okay? And now we're ready to go. I think we can algebra this. All right, here we go. Ooh, look at that, it gets darker when you retrace it. Okay, so first off though, notice that the mass, the inertial mass that's in the kinetic energy and the gravitational mass, these are the same. We think they are. We think that's actually true. Okay, so I'm actually going to do this without that factor in each of these terms. Okay, so 0.5 times 1,050 squared is 551,250. 250. And then this term here, the opposite of 6.67 E minus 11 times 7.35 E22. My dog wants to get out of the room here. Divided by 1.737. My dog is thinking, this has got to be the boringest video ever. Okay, divided by 6. So this term here is negative. All right, and then that equals 1/2 v squared plus, and then let's figure out this term here. Okay, so this is actually, this radius is 2.037 E6, there we go. So this is 406.031, that's a 4. All right, and I'm doing that again without this 0.0028 in there, okay? And now we're set. Now all I have to do is, I guess, solve for this v here, right? So I'm going to take this guy, and I'm going to add this guy. Then I'm going to subtract this term. And I've got 1,350.84.882. Let's see, I guess I'm special when it comes to commas here. Let's see. There we go. And then that equals 1/2 v squared. So there's no comma here. It's 135,584. So let's see, multiply by 2 raised to the 0.5. 520.7396. There you go. Enjoy.